This is representing a full muscle like the biceps. You can totally tell that it resembles the real biceps, but really we're just using this to help us understand motor unit and motor unit recruitment. So pretend this is a whole biceps, like a cross section through it. Each of the pencils is representing an individual muscle fiber. The ones that I colored with black Sharpie are representing the fast twitch fibers. The ones that I didn't color in black Sharpie are representing the slow twitch fibers. Each muscle is subdivided into multiple motor units. So for example, this little grouping of fast twitch fibers would be its own motor unit, and then we could come over here and say this grouping of slow twitch fibers would be its own motor unit, and each one of those motor units would be controlled by a different motor neuron. The other reason why this is so important is because there's this thing called the all or nothing principle. And what the all or nothing principle says is that when that motor neuron fires or sends the signal, every muscle fiber that it controls will contract at full force. And so think about how important that is now to have individual motor units or the whole muscle broken down into multiple motor units. Because think of the opposite. What if we had one motor neuron controlling every single muscle fiber per muscle, so like one giant motor unit per muscle? You could see that that would be a big problem for the signal being sent into that muscle, because every time that motor neuron fired, every single muscle fiber of the muscle would contract, and we'd be contracting at full force with every single muscle, and that would be a problem with force modulation, right? But because we have these muscles broken down into individual motor units, it really helps us to modulate force based upon the activity we're engaging in, or if, I'm lifting a probe versus a very heavy weight. This is representing a full muscle